to be picked up for that particular. So as I mentioned that flue gas cleaning, today we are talking with the objective of flue gas cleaning with this dryer. And after this dryer, as I mentioned that we achieved 150 to 190 milligram or maximum 200 milligram per normal meter cube of emissions. So just visualize after the gas is passed through the drying process, without any ESP, without any conventional ESP, without any scrubber, without any pollution control device, what you get? You get the gas volume to the 70%, I mean 30% reduction in gas volume because of the temperature coming down from 140 to 70. So you have a temperature volume reduction, the particulate reduction from 4,000 to 200 milligram maximum I'm talking in the worst condition. Otherwise most of the plants are getting around 110 or below 150 in most of the cases. But I'm taking the worst condition when sometimes the boiler is running at a lower load and the gas quantity of bagasse is less. That time the emissions can go up because you have a less material to scrub the whole amount of flue gases. Correct? So you have a gas volume of 70%, which is almost 30% down, and the particulate emissions are down by over 90%. So what to do after this? Because 200 milligram may not be acceptable or is not acceptable to the CPCB. So after the dryer, we thought three options. First option was to use dry ESP as a conventional ESP. But this was ruled out because the gas has become moist. It is near to the saturation point, and using the dry ESP was completely crossed because you cannot clean the collecting plates by hammering if you have wet gases in the system. Then we had an option of standard wet scrubbers of high efficiency, but again the limitation was that most of the scrubber do give you 80 milligram as an outlet emission from 200 to 80. The quantum does not matter in absolute terms. The matter is what is left out, and the left out, this 200 milligram is all fines. Most of the particulate in this 200 milligram was less than 15 or 20 microns. That means when we have a majority of fines, then getting the efficiency from a scrubber, you need to give a lot of high pressure drop, and that needs lots of energy. So up to 80 milligram, normal scrubbers can be used at a reasonably okay or well pressure drop, limited energy consumption. But when it comes to below 50 milligram or below 30 milligram, the wet scrubbers were also not having that much of priority because that needed a pressure drop of more than 180 mmWc. Then the third option, which was the most advanced option, our whole attention then went to the wet electrostatic precipitator. In sugar industry, when we started talking about wet ESP, not even a single installation exists in sugar industry of wet ESP across globe, not only in India. No wet ESP was installed before this installation. The reason was that wet ESP was considered to be the most advanced technology, but it was being used because it was costly affair. It was being used only for the complex solutions like tar removal in a steel industry or sulfuric acid mist removal in smelter plants. So since it was it was an imported technology, there was no technology available in India. So we made a lot of visits to European countries, and then we landed up in Sweden with a collaborative and a partnership on this wet ESP. But the challenge was that there was no reference in sugar industry on bagasse fiber. So that is how this beginning of developing this partnership with a Swedish company started in year 2017 on this particular model. Before that, we had installed a couple of 𝗓𝗔𝗄s in a steel plant and giving the results to the tune of 1 to 2 milligram per NM3. That means there is no problem in achieving the efficiency in 𝗓𝗔𝗄. The only challenge was that it was not used in, it has never been used in sugar industry across globe. No reference was there. So the challenge was taken up. The team of 𝗓𝗏 Sugar Works also visited with us in Sweden and saw a couple of installation. And when everything was lined up, when all the team members were satisfied, we collectively decide to go with this hybrid model of bagasse dryer. From the pollution board point of view, there was no issue because it is an ESP. It is an ESP, and ESP is approved as a pollution control device. It is nowhere mentioned it is wet or dry. So we landed up on this solution for a high efficiency cleaning device. And because most of the people may not know about the difference of wet and dry ESP, so let me just take you some time on explaining the principle of wet ESP. So wet ESP is nothing but a normal ESP, but it is in a vertical designed in a vertical fashion. It uses the saturated gas. It cannot be operated on a dry gas. It needs a saturated gas environment. It has a compact sizing. The efficiency what you get in dry ESP at 80 to 100 kV, you can get much higher efficiency here at 30 kV, because the water plays a dominant role in charging of the particles. Here, because the gas is saturated, you have a water layer on the particles. Already the gas is moist, the particles inside are moist, covered with a very thin water film. And when you have a water being a good conductor of electricity, the charging or the migration of the particles are much faster as compared to normal ESP. So this is how this particular phenomena makes wet ESP the most advanced design for pollution control or the emission control, even for the particles below 5 microns, 2 microns or submicrons. Correct? And we have seen it running at below 10 milligram in Sweden at many industries on wood chips fired boilers and other agro-based fired boiler. And this is how we call it as a gaining while greening concept. You gain and greening the environment. So if you look at the working principle of this wet ESP, you find that all the steps are same as normal ESP, except in the first and last. In the first step, the gas conditioning has to be done, and with the dryer does this work. So this step is completely eliminated when it is integrated with the dryer. The gas is already saturated or very near to the saturation after coming out from the dryer. So we have simplified the process of wet ESP, reducing the requirement of water. The major requirement of water in wet ESP is on gas conditioning to make the gas saturated. But the dryer has already done that work here. So you don't need any water, continuous water in wet ESP. In that case, if the dryer is reducing the temperature to 70, you don't have to use much water for making it saturated, right? Then charging is a simple process. You have particles are negatively charged. You have an electrode, emitting electrode, and then the positive collecting pipes. Here, there is no collecting plates. Here, there are collecting pipes in a honeycomb construction. So that they are grounded and have a positive charge. And the wet particles, when it is negatively charged, are migrated towards the positive. And then there is a layer on this. And this layer is removed periodically by water flushing, not by hammering like in normal ESP. So the last step, the removal of particle, is different. It is not mechanical hammers. It is by flushing of water. And then first step is different by making the gas saturated. The charging and collection is the same principle, but at a different intensity. Correct? So friends, should I move forward? Is everyone following the concept so far? If yes, please write yes in the chat box. Thank you so much for your active participation. You have been very, very good and fast on the chat box. Thank you. So let us move forward. And this is how the hybrid model was innovated. You can see this is a combination of dryer and a vertical wet ESP. And this is the actual 3D model, what was discussed and finally made for the first installation. If you look at the major takeaway from this integration, I'll just summarize what we have got out of this integration. And if you look at this, you find that flue gas cleaning is taking place with the bagasse drying. In one shot, you have an integrated model which can not only dry the bagasse, but also can clean the flue gases down to even below 30 milligram if so desired. The drying of bagasse gets you the revenue in the form of bagasse saving or prolonged cogeneration. A smaller footprint and compact layout because your gas is already 30% lower in volume, plus the specific collecting area required in the wet ESP is almost 1/4 of the dry ESP. The size of the wet ESP is very, very compact. And since it is vertical in nature and you have the honeycomb type of electrodes, collecting electrode, that needs if you talk about the footprints, it is I think less than 1/5 or 1/6 of a normal ESP. Correct. It has a capability to reduce the emissions to below 10 milligram if so desired. It is if in future if you have the less emissions prescribed by CPCB, you can further extend and upgrade it. So cleaning efficiency 99.5%. Yes, another feature which I'm going to describe here, in many plants, like normally the bagasse or biomass does not have much of a greenhouse gases excepting the CO2, and you have a very little amount of sulfur in some cases, but it is the traces and NOx as well, and some amount of this carbonic acid is formed during this process. So the wet ESP is a proven and known solution for condensing and collecting these small quantity of gases, because wet ESP is used as a smelter plant for producing the sulfuric acid, converting the SO2 and SO3 into the sulfuric acid. So that means it has a capability to condense and capture this mist particles or the aerosols, which we call normally. So it can reduce the greenhouse gases, low power consumption because you have a very low voltage, operating voltage, and substantial control on aerosols. So if you look at the biomass as a fuel for power or sugar industry, you find that all these takeaways are very, very favorable for the industry. Unlike in normal ESP, you have lots of issues of fire hazard in case of dry ESP. Here, that hazard does not exist at all. So before I now I am going to take up the two case studies in short, and then the first case study, let us take. The first one is from Balrampur Chini Mill, and this is a stand-alone dryer on a 80 TPH high pressure 87 ETA boiler, cogeneration boiler. And this was commissioned in 2020. And you can find the design parameters of this installation was 80-ton boiler. The bagasse dryer capacity was installed as 31 tons. 49% was the inlet moisture of the bagasse, and 140-degree temperature was there as a flue gas after the ESP. This boiler has got a ESP already, dry ESP. So the dryer was planned after ESP. It is not a hybrid model. It is a standalone dryer. And the output parameters guaranteed were 39.5 was the moisture, down by 10 units or 20%. Temperature of flue gas at the exit 70 plus minus 2. And the predicted pressure drop was 135 plus minus 10 across the dryer. And if you look at the data collection, this is average of 4 tests conducted for the performance guarantee at site. You find that boiler design parameters were this. With dryer, what we achieved, the steam generation went up to 87. 71 was there in one of the tests because the demand of steam was not there. That is why we have written 71 as per the demand. But it went up to 87 at the peak load. Pressure, temperature were maintained. Temperature was gone up by 2 degrees. Steam temperature we are talking about. Feed water temperature 180, 186. Flue gas outlet temperature, what we received actually from the ESP was 133 as against 140, the design parameter, and the outlet was maintained at 72. And the moisture reduction was from 48 to 50 down to 38%. And GCV went up to 2825. And fuel temperature, like normal bagasse, which is coming from the mill, is having around 30 to 40 degree. But since this cogeneration plant is located across the road in Balrampur, if many of you must have seen that, the temperature was around 30 plus. And after the dryer, the temperature went up to 50 to 65. You can see this is the photograph, the dry bagasse color and this mill bagasse. This is incoming conveyor to the dryer and outgoing conveyor from dryer. You can see this change in color because of the temperature as well as moisture evaporated. And this is the DCS output, what you see. And if you analyze all this result, I'll just show you a video of the final outlet gesture moisture. So if you analyze the gains, you can find that bagasse moisture 9.63 per unit. GCV went up by 18%. Thermal efficiency 6%. Steam economy by 11 to 12%. This is the raising of the boiler. Flue gas temperature to the stack 72. That means a drop of 61 delta T, which was used for bagasse drying. And excess air reduction. And then CO2 reduction to the tune of 30 to 35 tons equivalent per day. And then SPM reduction, then NOx and N2O reduction were noted to this tune. And if you look at the overall ROI of the project, with only 3 rupees cost of tariff, power tariff, you can find out this saving on per day basis. So this led to the ROI with the reduced tariff is about 500 working days in this particular installation. I'll just show you a video. I think most of you have seen, but I'll just rerun it. Just a minute, gentlemen. I think audio is not clear. Let me just reshare it. Okay, can you do it?
We are at one of our projects. Let's hear more about this project from the horse's mouth. the three key members of project execution team of 𝗓𝗏𝗆, Mr. 𝗓𝗵 from project, Mr. 𝗓𝗏𝗆 Singh from commissioning side, and Mr. 𝗏𝒏𝒻 यादव from construction side.
𝗓𝗏𝗆 को ये ऑर्डर लॉकडाउन के शुरुआती दिनों में अवार्ड हुआ था। इतनी मुश्किल कठिनाइयों के दौरान भी हमने इस ऑर्डर को टाइमली कंप्लीट किया है। ये बगास ड्रायर हमने 80 टन बॉयलर, हाई प्रेशर बॉयलर के लिए डिज़ाइन किया है। इसमें मॉइस्चर रिडक्शन 18 से 20% का रहता है।
𝗓𝗏𝗆 इंजीनियर्स ने 80 टन बॉयलर के लिए बगास ड्रायर सप्लाई किया है, जिसकी कमीशनिंग हमने 30 नवंबर 2020 को किया है। और ये ड्रायर बगास ड्रायर हमारे एक्सपेक्टेशन से बहुत ही अच्छा वर्क कर रहा है और ये हमारा 8वां सक्सेसफुल कमीशनिंग है और हम इससे 18 से 20% मॉइस्चर रिडक्शन गेन कर रहे हैं और एमिशन लेवल भी हमें जो हमने अपने पीजी पैरामीटर में दिया है वो हम गेन कर रहे हैं। और आइए हम आपको अपने ड्रायर सिस्टम के बारे में एक्सप्लेन करते हैं। आइए ऊपर चलें।
ये अपना ड्रायर इनलेट आरएबी है जो कि वेट बगास को अपने ड्रायर सिस्टम में फीड करता है। ये ड्रायर सिस्टम का साइक्लोन सेपरेटर है जिसमें फ्लू गैस और बगास को सेपरेट किया जाता है।
Okay, thank you so much for watching this video. Now coming to the case study 2, which is of the hybrid model from DSW, Dorala Sugar Works. As I told you, this was put up on a new boiler. It was conceived in the beginning while setting up the boiler, and this is the layout. This is the air preheater outlet, and then you have a flash tube followed by the cyclonic separators, and then connected with the same top entry wet ESP, and the outlet gas is going to the ID fan and then to the stack. So since it was conceived with the boiler itself, when boiler was under installation, this whole the layout was done properly in a, I would say the footprint was almost 12 to 15 meter lower than the normal boiler when you have a dry ESP. And this was the design conditions, input and output parameters for this particular boiler. This was a 90-ton boiler. Moisture of bagasse was 50, inlet 67 eta, and 505 temperature, gas steam temperature. And if you look at this performance data with hybrid bagasse dryer, you find that input parameters 140 temperature, outlet temperature 71, and flue gas temperature at west outlet was 68, wet ESP outlet. That means there is a drop of about 3 degrees in wet ESP. Moisture reduction from 50 to 40, and this is the draft loss to the tune of 130 mm. And across ESP, wet ESP, the draft loss was only 20 mm, which is normally similar to the normal conventional ESP. As far as the particulate emission on flue gas cleaning side, if you look at, the inlet to the dryer was 4,000 milligram per nm cube, which is a standard for a normal bagasse fired boiler, having PI or preparatory index of cane in the range of 85 to 90. So you get about 4,000 milligram. So outlet of dryer was, tested at 195 milligram. And then after wet ESP during the test, it was 35 milligram per normal meter cube as against the 50 milligram, which is guaranteed. And the waste collection efficiency was taken to the tune of 82%, but on all fines condition. These are the comparative data. I will just run through quickly because it has the analysis has been done from various parameters just to give you a feedback or give you a little idea what a hybrid model can achieve the different dimensions in a boiler circuit. If you look at the steam generation rate, bagasse consumption, flue gas flow rate reduced from 156 to 135, flue gas volume reduced after wet ESP, and then bagasse consumption reduced because of the dryer. And when the bagasse consumption is reduced because of the drying process, your bottom ash discharge also reduced from 550 to 500, around 10% reduction. And reduction in solid waste discharge is to the tune of 1.2 tons. And on volume side, if you look at, the volume reduces and the SPM reduces, leading to the absolute particulate discharge reduction in absolute terms. You know, we are normally talking about the milligram per normal meter cube. That is okay. That is one criteria from pollution control board point of view. But when you look at the absolute, in absolute terms, your volume is reducing, and your bagasse consumption is reducing. That means the overall dust emissions on absolute terms on a 24-hour basis is also reducing drastically. And this criteria in many of the European countries, the milligram per normal meter cube is not making much of a sense unless you talk about the emissions in absolute terms. The milligram per nm cube can be reduced by putting more air into the flue gas. That does not mean that you are fulfilling the requirement. Okay, from CPCB point of view, you might be fulfilling, but if you look at the total emissions, absolute emissions going out of the stacks are still high. So if you look at from that point of view, this hybrid model is also reducing the absolute emissions to a great extent. And SPM, if you look at this special cleaning feature of this hybrid model, 8 to 10% absolute reduction because of the lower fuel consumption. That means the 30 milligram per nm cube, which we are talking, will result into 30 milligram net if you compensate for the reduction in volume in terms of absolute emissions. So flue gas volume reduced by 8 to 10%. This SO2, since bagasse does not have sulfur, so we have not talked about SO2 in case of bagasse. But when you have some other biomass having a traces or little amount of sulfur, that also can be taken care of by 𝗲𝗔, because 𝗲𝗔, as I told you, is known for removal of aerosols. Whatever gaseous pollutant which can be condensed or which at that temperature, at dew point, that all will be removed, because the water particles or the mist of acids gets also charged electrically in the 𝗲𝗔 and gets accumulated on the surface of the honeycomb, correct? And this NOx reduction is also there, more than 10% due to lower quantity of fuel fired and increase in furnace temperature. So friends, this is the average value of 4 tests conducted during the season. And you can look at on an average of 11 unit reduction in moisture, 30 to 35 milligram of dust emissions, and the pressure drop is from 130 to 280. That means around 150 in total. So let me summarize whatever we have discussed so far. Benefit from a hybrid model. Please listen it carefully, because this is all the crux what we have discussed so far in nutshell. There are qualitative gains and there are quantitative gains. And let me read the qualitative gains first. Bagasse drying and flue gas cleaning in one shot, meeting the CPCB futuristic norms of emissions. It has a substantial control on gaseous pollutants, unlike any other pollution control device like ESP or bag filters. Low power consumption because of the lower voltage required. Carbon emission reduction with increased green power and lowered greenhouse gas emissions. Smaller footprints. And in quantitative, if you look at the particulate emission efficiency, collection efficiency is more than 99.1%, 22% reduction in the bagasse moisture. Net bagasse saving goes from 6 to 7%, so on an average 6.5%. Productivity enhancement in terms of steam generation can go up. In many cases, it has gone up by 8 to 10%. provided you have a margin in the boiler feed pump, of course. And then carbon emission reduction equivalent to 30 tons of CO2 equivalent per day, or 900 tons CO2 equivalent per month. Revenue generated is about 160 lakhs per season, considering 1.3 megawatt of extra power at the rate of rupees 3 per kilowatt for 170 days crushing season. That means you are getting a revenue of 160 lakhs even at a lower tariff value. Sometimes you don't have to produce the power if the bagasse rates are expected to be higher than 1700, which is the case as on date. Then selling the bagasse to other industry can fetch you more money from this model. So we have to see which way to go depending on the economics of that particular time, depending on the price of bagasse, depending on the power tariff. And these objectives, as I told you, can vary from geography to geography, from mill to mill, and from boiler to boiler. So an overview is meeting the pollution norms, emission norms with return on capital investment, and greening while gaining while greening is the concept which is followed here. This technology has been awarded and accoladed at various forms. We have a patented already awarded, and end users from Balrampur as well as from DCM, Excellence Award from STAI, and then the recently awarded this most innovative product of the year 2021 by CII.
With this, we move to the next category of awards, the most innovative energy saving product. Out of over 20 applications that were received this year, the panel of judges had shortlisted 3 of them to come and make presentations in front of the jury. And the panel has selected 𝗕𝗏𝘆 Engineers Private Limited for their innovative hybrid dryer for bagasse as the most innovative energy saving product for the year 2021. Some of the unique features of this was a unique revenue generating APC model for sugar industry, something which the sugar industry has been looking at as a dryer for bagasse, a very innovative technology. The panel of judges have chosen 𝗕𝗏𝘆 for the most innovative energy saving product for the year 2021. Congratulations, 𝗕𝗏𝘆 team.
And friends, just to add one thing, that in this jury members of this CII, there was no one from sugar industry when we presented this case. Most of them were from different industries, and even in that situation, they acknowledged this contribution of this hybrid model for environment as well as producing green energy.
With this,
so as a summary, if you look at what a hybrid model can deliver for a, let us say for 20 megawatt, we take a case of 20 megawatt for the understanding purpose. And for a 20 megawatt bagasse based cogeneration plant, the hybrid model can give you and produce extra green energy to the tune of 1.2 to 1.5 megawatt hour. It can deliver the particulate emissions to the tune of 10 to 50 milligram per nm cube. And also it has a potential to reduce other pollutants and gaseous pollutants. And if you look at the table, since the SO2 is absent, it is not recorded here. But even if the SO2 is there, it will reduce to a great extent. We need to see what is the input and how, and whether the water can do it, or we need to make this flushing water a bit of alkaline to remove more SO2 from the system. And mercury, the heavy metals were absent, so it is not recorded, but it has a capability to reduce mercury. The heavy metals also gets electrically charged in the wet ESP and can be separated. Amino acid with the little alkaline water scrubbing, this also gets reduced. And gaseous pollutants, as I mentioned already, it has a capability to reduce 1000 to 1350 tons per month of CO2 equivalent. So in nutshell, if I talk about this hybrid model, which is producing the clean and green energy and reducing the greenhouse emissions to the climate. And if you see, only in sugar industry in India, you have 500 sugar mills and 8,000 megawatt of bagasse-based cogeneration is presently available in India from the sugar mill. And hybrid model of bagasse dryer has a great potential for replication to produce from the sugar mill itself. We are not talking of other industries using biomass as a fuel. If you add all those, then the potential goes multifold. But only in sugar mills, if it is applied, you have a potential to produce clean and green energy to the tune of 2100 gigawatt. Reduction in this greenhouse gases to the tune of 2 million tons of CO2 equivalent. As you know, our government has committed at an international platform in Glasgow that by 2020, we are committed to reduce 1 billion tons of CO2 emissions. So in that situation, and by 2070, we are going to be net zero in carbon emissions. So my friends, with this hybrid model of bagasse drying or the biomass drying, we can contribute towards that commitment of our Prime Minister or the nation commitment to the international community. And it has a capability only from sugar industry, 2 million tons, as against the commitment of 1 billion by 2030. And this can go multifold if we cover other industries in that. And this is only for 170 days of sugar crushing season per year. There are many industry who works around the year and using these biomass as a fuel. So there the return on investments are going to be much higher. So the concluding slide, that this hybrid dryer, or we call it hybrid WESP from the CPCB point of view, it could be a way forward to view the investment on APCD, air pollution control device, a revenue generating and rewarding, rather than viewing the air pollution control only as a dead investment, just to meet our social commitment and just to be good on papers with CPCB. The integrated wet ESP being the most advanced solution as available across the globe, and its presence as the last equipment before its tech makes the hybrid model a perfect device to maintain cleaner environment even during varying operation condition of bagasse dryer. I mentioned this point specifically because, as you know, the last equipment before the chimney has to be a pollution control, has to be an approved pollution control device. So when you talk about hybrid model, the wet ESP becomes the last equipment before ESP, before the step. That means this is within the guidelines of the Pollution Control Board. This is well within the guideline of the Pollution Control Board. It is the most advanced solution in the world. It has a capability to reduce this greenhouse gases as well as the solid particulate matter. And it can also be extended. This model can also be extended to other high moisture fuel like bagasse pith, mustard husk, and many other agro-based, the rice husk. And then we are also making a lot of trials on wood chips fuel, and also the trials on lignite and coal drying also in the pipeline. But we are not ready yet to launch that solution. But very soon we will be coming out with a solution to reduce the moisture in all type of fuels, and so that our power plant and power generation become more eco-friendly and can reduce the carbon emissions. By 2070, we are supposed to be net zero carbon emission. So this is one step towards achieving that goal of 2070. Thank you so much, friends, for your patience hearing. And now we will have a question and answer session, and our backend team will also just float a link where you can just fill your name and download your participation certificate. But just before that, let me just give you the upcoming event. The webinar 3 of the series is going to be on 25th of February, Friday from 4 p.m. And the topic is going to be the innovative ways to upgrade your existing APC devices across industry to meet more stringent pollution norms. Rather than replacing, it is an upgradation of the existing. As you know, the pollution norms are getting more and more stringent. So many plants are due for upgrading their APC. And when they talk to different kind of supplier, they receive different kind of advices. So we are going to present at one solution like this equipment, this is the solution for upgradation. This equipment, this is the solution. So everything is coming to be under one roof. You can have various options of upgradation, and this is going to give you a lot of insight so that your decision is right when you take up the upgradation or the replacement of the equipments. So thank you so much once again. And Prakhar and our marketing team, are you ready to float that link?
Yes, we have already floated.
Yeah. So friends, please download that link and just fill up your name, and you can download your participation certificate before we proceed to the Q&A session. We'll have a 30 seconds for doing that. And then go for Q&A. So whatever questions have come to your mind or coming to your mind, please put it in the chat box. We will be replying one by one to the extent possible. If something is left out, please forgive me. But definitely we will be coming back on an email reply on one-to-one basis if something is missing. I hope people are downloading their participation certificate. So let me just wait for another 30 seconds before we go to the question and answer session. Okay, so we begin with the quick Q&A session now, and I will be taking up the questions one by one. So I hope everyone is ready for the Q&A session. Just give me a moment. Let me just scroll down. Thank you, Mr. Bhojraj, for your blessings and for your greetings. PM is particulate matters. The next question is, yes, the question is from Dilip. The question is there any increase in fugitive emissions while drying the bagasse in sugar plant? Mr. Dilip, as you rightly picked up the crux. See, if you look at the cyclone design, if your design of cyclone is good, then there is no fugitive emissions which are created. The other thing where the fugitive emissions can take place is the belt conveyors. when you are taking the dry bagasse out of the system and taking it to the boiler feeders, that time there are chances of fugitive emissions. So we normally advise, and whenever it is in our scope, we give a completely sealed belt conveyor from all sides, especially for the return side, the dried bagasse conveyor. And also the dry bagasse conveyor is running at a faster speed than a normal conveyor, so that the dried bagasse reaches as fast as possible to the feeder of the boiler to reduce or minimize the chances of taking back the moisture from the atmosphere. So you have to take care of these, and otherwise there is no much appreciable fugitive emissions are recorded from any of the plant. Next question is next question is from Mr. Sudhir. How much water is required? I suppose he's talking about wet ESP. So if your flue gas is completely saturated in dryer, then you need water only for the flushing cycle, and that is hardly 1 to 2 meter cube every 4 hours for cleaning of electrodes. So it is a very nominal water. But if your dryer is not saturating the gases because of some reason, maybe sometime you have a low load on the boiler and your quantity of the gas is lower, in that case we have an option above between the dryer and that is called for gas conditioning tower, and that takes care of the saturation point if the gases are coming at high temperature from the dryer in certain conditions when the quantity of the gas is lower. But on an average, 2 to 3 meter cube maximum water is required every 4 hours for a 110 boiler. Right? I hope I have replied your question. And this water can also be recirculated after separation of solids. From the separation of solid can be done in a similar way like you do for wet scrubbers. Mr. Sudarshan, can we have a capex comparison? I don't know from which system you want us to compare, but if you look at the dry ESP followed by dryer versus hybrid dryer, then hybrid dryer is going to be, I would say it is comparable with that because wet ESP is a little costlier technology. It is imported technology from Sweden and other European countries. But here in sugar industry, especially with the dryer, cost has come down because of the reduction in volume and because of the reduction by over 90% on the particulate emissions. So the ESP followed by dryer versus hybrid dryer, if you compare, the hybrid dryer is going to be more economical in OPEX as well as in CAPEX. It is going to be almost same. For selection, what parameters are considered? Mr. Rajiv Mittal, thank you, Rajiv ji. This for selection, if it is a new boiler, without then directly the hybrid model can be conceived with the new boiler. There is no need of dry ESP. You just have air preheater followed by dryer and integrated wet ESP is the best solution. But if you have some boiler already existing having either a scrubber or a ESP, then you have to figure it out which preposition is going to be more economical. With ESP, normally the dryer is being put up after ESP. With wet scrubber, the dryer is being put up before wet scrubber, and the outlet of dryer is then let out either directly if the norms are 150. If the norms are lower, then it passes through the existing scrubber once again. Next question is again from Dilip. Do you go for carbon footprint in industry for audit too? Dilip ji, it has not been done yet, but we are putting up this to the industry and to CPCB to have a carbon credit for this. What is the optimum excess air allowed? Mr. Suraj, this excess air depends on your boiler design and combustion, but in a bagassified boiler, 30 to 40% excess air is permitted, is normally the design figures. But as you go for high pressure boilers, sometimes it's even less than 30%. What is the equilibrium moisture content of bagasse water system? Equilibrium moisture content of bagasse. I have not followed this question. Mr. Bhojraj, I will come back to you on one-to-one basis. What is the water content to achieve saturation? Yeah, the above question by, okay. The water content, I mean, if you have a 50% moisture in the bagasse, then the gases of that particular boiler are coming to very near to the saturation. That means it has a capability to come down to about 70 degree from 140 degree. But if your temperature of flue gas, if your boiler is inefficient and the temperature of flue gas is higher than 140, then you might need either more bagasse to get it saturated, or you might need a fogging system, as I told you, the gas conditioning tower in between the dryer and the integrated wet ESP. So we as a model have a provision of having a fogging system or the conditioning tower above the top wet ESP, just to address the situation and concerns during the emergencies. Thank you. Please share data. Yes, we are returning. I'll wait for the audio. Please share real-time data of BCML. Yes, Shuklaji, this is what I have presented is all cumulative and the aggregate of real-time data only. But if you want the log sheets and others, we can discuss on one-to-one basis. Mr. Shivam Srivastava, I heard your ethanol is now produced from bagasse at sugar mill. How, just a minute. How economical producing ethanol versus using it fuel in boilers? Okay. Shivamji, this needs a lot of, a discussion on a different platforms. You are talking of bagasse as a fuel versus ethanol. So I will not be able to reply on this directly. I'm sorry. We can discuss it separately over the email or on phone. Thank you. Thank you. Too much disturbance, 5 times disconnected. Okay, thank you. We will take care of this. What about erosion of impellers? The ID fan are located after the wet ESP. It is handling a very, very clean gas. So there is no question of erosion of a scrub fan. But yes, there is a threat of mild corrosion, definitely, because the gas is totally saturated after wet ESP. So necessary precautions are taken in the ID fan design when you design an ID fan for a wet application. Correct? But fans are available for wet application. Plenty of suppliers are supplying these type of fans. For selection, information is basically the boiler information is required. The flue gas volume is required. The temperature is required. And we will send you the questionnaire, Rajiv ji, very soon on this. Life expected of a fan impeller, if it is after wet ESP, the life can be as high as 5 to 8 years, depending on the material selection for the fan impeller. How much percentage of ash will be recirculating along with dry bagasse? Yes, Mr. Srinivasa. It depends on unburnt carbon or the unburnt or partially burnt particles coming from the boiler. If your boiler is efficiently working, if your boiler furnace height is good enough, if it is not a very old boiler, then the percentage of unburnt or partially burnt particles coming and mixing with the bagasse in the drying process is I would say it is negligible as compared to the quantity of bagasse. So if you look at even without any APCD before dryer, you find the minor change in color of the bagasse because of these carbon particles. So it is very, very negligible if you compare the total bagasse quantity. It is hardly less than, I would say, 0.5% approximately. So we don't have to worry on that unless and until you have lot of silica content in the bagasse, especially for overseas project where the mechanical harvesting is there. We need to be careful on this particular aspect of recirculating the silica present in the bagasse with the bagasse after drying. So there you need to be little careful on selection of material and the quantity of silica which is coming on way with the bagasse. Are you sure the size of particulate matter uniform? Not at all, Mr. Dilip. Particulate size is not at all uniform, and that is the reason the APRT concept is followed, the average particle retention time. And if you have a bigger particles, it needs more time for drying. If it is a smaller particle, it needs less time of drying. So you can't satisfy every particle in the same system. We are talking on average basis, the average moisture reduction, the average particle size, and the average retention time. So this is all on the average basis. And if you have a very big particle sometimes, which is for which the cyclone, the retention time is not enough, then in that case, that particular particle will have a more moisture. But when you talk about the average basis, it is averaged out, and then we have a collective cumulative average. Next, data for reduction of clinker formation in furnace with dryer, please. Yes, Dilipji, we in terms of numbers, I do not have this data, but definitely the our observation in various plants, whatever projects we have done in last 10 years, we have done almost 10 dryers. Including in outside India, we have seen the clinker formation has gone down drastically. Wherever there were heap formations, the heap formations have almost diminished, because the majority of particles, bagasse particles, after drying burns in the suspension. So there is very less amount which is falling on the grate. And when you have a less amount falling on the grate, you have a less chances of clinker. And especially on bagasse white boiler, that threat is not much. Definitely, I have noted this point. We would be in our next project or in the running project, we will try to see with or without dryer if some figure can be measured in this. Thank you, Dilipji. Next question, please inform me approximate cost, delivery time, installation and commissioning. Cost will vary totally on the layout and the type of system we are working on. So it has to be plant to plant. It is not right for me to say anything on that part in this forum, but on delivery time and installation commissioning, if it is a hybrid model, it will take around 6 to 7 months. And if it is a dryer standalone, then it might take 1 month lesser. That's all. Next question from Pawan Senegar. How can it help in paper industry? Can it be helpful in using moisture? Pawanji, I think in paper industry, at many places, the bagasse pith is being used as a fuel with the coal as a supporting fuel in most of the captive power plants. So this concept can definitely be applied, and we are going very aggressively in paper on this, and will be closing 1 or 2 projects very soon, and targeting on CPP of paper plant to dry the bagasse pith or other type of or any other type of biomass being used as a supporting or the main fuel in the CPP. When BD with BESP is used, have you checked the unburned dry ash analysis from hoppers? What was the improvement? Yes, Mr. Mohan, we have checked, and we have a data from our first installation on unburnt, and the unburnt has got reduced by more than 60% from the hoppers of aerator, economizer, and from the riddling hopper and from the main bank hoppers. The unburnt has reduced because you are again and again circulating that particles back to the furnace. And on the front ash also, your color of the ash also gets a little bit whitish, because the particles, the black particles are getting circulated and get completely burnt. So your unburnt is reduced from the hoppers as well as from the bottom ash. Mr. Prashant Sagar, can this system work on mustard husk? Yes, apparently on mustard husk it can work, and we are working on a proposal for mustard husk at the moment, because the husk husk sizing, particle sizing is quite similar to the bagasse. So on the pneumatic conveying side, there is no threat. The only thing, I think the husk has got some amount of chlorides. So we have to be careful on the corrosion and sticky nature of those things. But definitely the concept is workable and we are working on it already. Mr. Narendra Mathur, would you like to know would you like to know about such application for biomass plant using mustard, other agro waste? Yeah, Mr. Mathur, as I mentioned, nobody has used it yet for mustard husk, but we are working on a proposal recently on a mustard husk, and this can be done. That is what our technical team has already studied, and this is possible with the slight changes in the metallurgy of the equipments. Thank you. Yes, Mr. P.K. Sarkar, maybe we replace our existing wet scrubber with hybrid system of 70-ton boiler. Definitely, wet scrubbers can be replaced or can be integrated with dryer. If you are not having the requirement of going below 70-80 milligram at the moment, you can put up a dryer before the scrubber and use a scrubber. We have a integrated scrubber model also. The hybrid model is designed in two variants. One is with wet ESP and another one is with low pressure drop scrubber, low cost solution. So your existing scrubber can be studied for converting into a low pressure drop top entry scrubber attached with a dryer. So you can maintain below 80 milligram easily with this combination. But if your budgets allow, and if you are looking for a futuristic solution, then go for a complete wet ESP model hybrid dryer. I think we have finished all the questions. Mr. Rajiv Mittal has got one question. Please send SLD of your scope of supply. We will be coming back on this definitely. Rajiv ji, I will be talking to you tomorrow. Okay, thank you very much. I think we have